Article 700.12c of the National Electrical Code, specifically within Article 700 pertaining to emergency lighting systems, addresses wiring method. Wiring for emergency lighting must adhere to the wiring methods detailed in Chapter 3. Importantly, the wiring extending from the battery to the luminaire needs to comply with Article 725. Furthermore, acceptable cable types for this battery to luminaire wiring include Type UF, Type US, or Type MC cables. To elaborate on Chapter 3 wiring methods, this chapter outlines a comprehensive range of wiring methods suitable for various applications. These wiring methods encompass different types of cables, raceways, and conductors, each with its own specific installation requirements and limitations. For instance, Chapter 3 covers topics such as cable types including non-metallic sheet cable, armored cable, and metal-clad cable, along with raceway systems such as electrical metallic tubing, electrical non-metallic tubing, and rigid metal conduit. Each wiring method detailed in Chapter 3 has specific application guidelines. These guidelines address factors such as voltage limitations, environmental conditions, and allowable ampacities. Proper adherence to these guidelines ensures the safety and reliability of the electrical installation. When installing wiring for emergency lighting systems, it is crucial to consult Chapter 3 to identify the appropriate wiring method for the specific application. Factors such as the building construction, the ambient temperature, and the presence of corrosive substances can all influence the selection of the appropriate wiring method. Moving on to Article 725, this article governs remote control, signaling, and power-limited circuits. While emergency lighting circuits themselves fall under Article 700, the wiring from the battery to the luminaire is treated as a power-limited circuit and thus falls under the scope of Article 725. Article 725 imposes specific requirements on the wiring used in power-limited circuits, including limitations on voltage and current. These limitations are designed to minimize the risk of electrical shock and fire. The use of Type UF, Type US, or Type MC cables for the battery to luminaire wiring ensures compliance with these requirements. Type UF cable, or underground feeder cable, is a type of non-metallic cable specifically designed for direct burial in the earth. It is resistant to moisture, corrosion, and physical damage, making it suitable for outdoor or wet locations. Type US cable, or underground service entrance cable, is another type of cable designed for direct burial. It is similar to Type UF cable, but has a higher ampacity rating, making it suitable for high current applications. Type MC cable, or metal-clad cable, is a type of cable consisting of insulated conductors enclosed in a metallic sheath. The metallic sheath provides mechanical protection and serves as a ground path, making it suitable for use in exposed or concealed locations. In summary, the National Electrical Code requires that wiring for emergency lighting systems comply with the wiring methods specified in Chapter 3. Furthermore, the wiring from the battery to the luminaire must comply with Article 725 and be installed using Type UF, Type US, or Type MC cables. By adhering to these requirements, the safety and reliability of the emergency lighting system are ensured. The National Electrical Code, or NEC, is a widely adopted standard for electrical installations in the United States. It is published by the National Fire Protection Association, or NFPA, and is updated every 3 years. The NEC provides comprehensive guidelines for the safe and effective installation of electrical systems, covering topics such as wiring methods, overcurrent protection, grounding, and equipment installation. Compliance with the NEC is essential to ensure the safety of people and property. Emergency lighting systems are a critical safety feature in buildings, providing illumination during power outages or other emergencies. These systems are designed to provide sufficient lighting to allow occupants to safely evacuate the building. Emergency lighting systems typically consist of luminaires, batteries, and a charging system. The luminaires are designed to provide a minimum level of illumination, while the batteries provide power in the event of a power outage. The charging system ensures that the batteries are always fully charged and ready to provide power when needed. Proper installation and maintenance of emergency lighting systems are essential to ensure their reliability. Regular testing and inspection should be performed to identify any potential problems and ensure that the system is functioning properly. Any necessary repairs or replacements should be made promptly to maintain the system's effectiveness. The selection of appropriate wiring methods for emergency lighting systems is crucial to ensure their safety and reliability. The wiring must be able to withstand the environmental conditions in which it is installed, as well as any potential physical damage. The wiring must also be properly sized to carry the required current without overheating. The use of Type UF, Type US, or Type NEC cables for the battery to luminaire wiring provides a safe and reliable connection. These cables are designed to withstand the rigors of the environment and provide a long-lasting connection. In addition to the specific requirements for wiring methods, the NEC also includes general requirements for electrical installations. These requirements cover topics such as grounding, overcurrent protection, and wiring identification. Proper grounding is essential to prevent electrical shock hazards. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect the wiring from overheating. Wiring identification is important to ensure that the correct wiring is used for each circuit. By complying with all applicable requirements of the NEC, the safety and reliability of electrical installations are ensured. The NEC is a complex and comprehensive document, and it is essential to consult the latest edition to ensure compliance. The NEC is available for purchase from the National Fire Protection Association, or NFPA, and can also be accessed online through various subscription services. It is important to note that the NEC is a minimum standard and local jurisdictions may have additional requirements. It is always advisable to consult with a qualified electrical contractor to ensure that all applicable requirements are met. In the context of emergency lighting, understanding the specific requirements for wiring methods is particularly important. The integrity of the wiring directly impacts the system's ability to function during an emergency, making proper selection and installation paramount. Firstly, selecting the correct wiring method is important. Factors such as the environment, voltage, and current requirements need to be considered. Secondly, proper installation techniques are crucial. This includes ensuring correct termination, support, and protection of the wiring. Thirdly, regular inspection and maintenance are necessary. This helps identify and address any potential issues before they compromise the system's performance. Furthermore, it's important to understand the different types of cables mentioned. Type UF cable is suitable for direct burial and wet locations, offering excellent resistance to moisture and corrosion. Type US cable, also designed for direct burial, typically has a higher ampacity rating for higher current applications. Type NEC cable, with its metal-clad construction, provides mechanical protection and can be used in exposed or concealed locations. The choice between these cables depends on the specific application and environmental conditions. In addition to the cable type, the correct size of the conductors within the cable is also critical. The conductor size must be adequate to carry the required current without overheating, and this is determined by the ampacity rating of the conductor. The NEC provides tables that specify the allowable ampacities of different conductors based on their size, insulation type, and operating temperature. Proper overcurrent protection is also essential to protect the wiring from damage due to overloads or short circuits. Circuit breakers or fuses must be installed in the circuit to interrupt the current flow in event of a fault. The overcurrent protection device must be sized appropriately for the ampacity of the wiring. In summary, wiring for emergency lighting systems requires careful attention to detail and strict adherence to the requirements of the NEC. By selecting the correct wiring methods, using proper installation techniques, and implementing regular inspection and maintenance programs, the safety and reliability of these critical systems can be ensured. It is important to note that electrical work should only be performed by qualified individuals who have the necessary knowledge and experience. Working with electricity can be dangerous, and it is essential to take all necessary precautions to prevent electrical shock and other hazards. If you are not qualified to perform electrical work, it is always best to hire a licensed electrical contractor to do the job. The electrical code evolves based on new technologies and potential dangers. The NEC is updated every 3 years to include revisions and address any new items. Staying abreast with the latest edition is paramount to ensure safety and code compliance. Understanding the nuances within each article, especially concerning emergency systems, is important. The emergency systems are designed to protect life and property, and their proper installation and maintenance cannot be overstated. Moreover, always consult local amendments or additions to the NEC adopted by your specific jurisdiction. Local codes may be more stringent than the NEC itself. These local variations often reflect specific regional concerns or requirements. In conclusion, navigating the NEC for emergency lighting wiring involves a multifaceted approach. It requires familiarity with general wiring practices in Chapter 3, specialized considerations for power-limited circuits in Article 725, and the overarching requirements for emergency systems in Article 700. This also requires careful cable selection, proper installation, and a commitment to ongoing maintenance. By carefully adhering to all applicable codes and standards, one can ensure the reliability and effectiveness of emergency lighting systems, safeguarding lives and property during critical situations. Emergency lighting systems also relate to fire alarm systems. Many buildings will automatically turn on emergency lighting systems when a fire alarm is triggered. This happens even if there is not a power outage, but the logic is to ensure that people evacuating the building in a fire situation have enough light to see where they are going. The emergency lights also help first responders who may be entering the building to address the fire. The NEC has specific considerations for fire alarm wiring and systems. It is important to consider these interconnections to ensure that both systems function properly and do not interfere with each other. The emergency lighting system may also have a generator that powers the system when there is a power outage. The generator should be properly sized to handle the load of all emergency lights and any other emergency equipment. The generator should be tested regularly to ensure that it is functioning properly and can provide power when needed. The NEC has specific requirements for generators, including requirements for installation, maintenance, and testing. The wiring for the generator should also be properly sized and installed to ensure that it can handle the load. When working with emergency lighting systems, it is also important to consider the accessibility of the equipment. The batteries should be easily accessible for maintenance and replacement. The luminaires should be positioned in a way that provides adequate lighting coverage and does not create any obstructions. The wiring should be installed in a way that allows for easy access and maintenance. The NEC also has requirements for the labeling of emergency lighting systems. The labeling should clearly identify the equipment as part of the emergency lighting system and provide information about the system's operation. This labeling helps building occupants and first responders understand how the system works and how to use it in an emergency. It is also important to consider the aesthetics of the emergency lighting system. While functionality is the primary concern, the system should also be visually appealing and blend in with the building's design. There are many different types of emergency lighting luminaires available, and it is possible to select luminaires that are both functional and aesthetically pleasing. The NEC does not specifically address the aesthetics of emergency lighting systems, but it is a factor that should be considered when selecting and installing the equipment. The emergency lighting system should also be designed to minimize energy consumption. There are many energy-efficient emergency lighting luminaires available, and these luminaires can help reduce the building's overall energy consumption. The NEC does not specifically require the use of energy-efficient luminaires, but it is a best practice that should be considered. Finally, it is important to remember that emergency lighting systems are a critical safety feature in buildings. These systems are designed to provide illumination during power outages or other emergencies, allowing occupants to safely evacuate the building. Proper installation and maintenance of emergency lighting systems are essential to ensure their reliability and effectiveness. By following the requirements of the NEC and working with qualified professionals, you can ensure that your emergency lighting system is properly installed and maintained, protecting the safety of building occupants.